In this set of notes, we're going to run through a review of parent functions and their transformations. So if we have a function, I didn't really mean to move that way, like y equals f of x, that's an example of a function. So underneath it here in green, you can see that I've got a couple of examples of what parent functions would look like. Y is x squared, y is absolute value of x, y is the square root of x. You see, they're very simple. They have no numbers really involved, just that single x with something to do with it. And then over to the right, I have done some adding and subtracting and multiplying over there. So the first question here says, what does the k do? So here's k, right here. Here's my k. What does the k do when I add it to the end of all of these different functions? So the k is going to move the parent either up, if it's a plus, or down on the grid, on the coordinate plane. What does the h do? Well, see, the h is right here. Here's my h. And so notice it's always on the inside of, here it's on the inside of the parentheses. Here it's on the inside of the absolute values, and here it's on the inside of the radical. So the h is always inside, and it gets either squared or taken the absolute value of or square rooted. So it's on the inside. And what does the h do? It's going to move the parent left or right, and it's going to be the opposite of what you think. So if you have a plus, then you're going to move it to the left, and if you have a minus, you're going to move it to the right. So what does the a do? So the a, so let's notice where the a is. The a here is in front of, let's see, make that purple. The a here is in the front, and it's multiplied times everything. It's multiplied here and here. And this has got a negative that's multiplied, a -1 there. So what does the a do? It's either going to stretch, it's going to make the y values taller, so stretch taller, or it's going to squish, that's a real mathematical word, squish smaller. Or if there is a negative, then it's going to flip the graph vertically. All right, so there's a quick review. So here we have our first parent. You can see it here. It says graph each parent function. So here my parent is y equals x squared, which is the quadratic function. We want to always focus on this point right here, which is 0, 0. So there it is. If I plug a 0 in, I get a 0 answer. And I want to think about that. So when I come over here to graphing y equals x minus 3 squared plus 2, I see inside of here I have a -3, so I know that it's going to go, our function's going to go right 3, and because of this plus 2, it's going to go up 2. So what's moving? So what I'm going to focus on is the original origin, which was here. I know that it's going to go right 1, 2, 3, and up 1, 2. So I hit right there. So when I translate that, right 3 up 2, I get the same thing. Now I could actually kind of count all those different points the same way. Every point that's on the parent, I could do that. I could also kind of look and kind of mimic what happens here. You can see these are these 2 points. And then I went over 2 and then up 4. So from here I went over 2, 1, 2, 3, 4. So you can kind of get the idea. 2, 1, 2, 3, 4. And here is my parent, and this is where it's located right there. So now what I want you to do is you try this one. Our second parent is the absolute value parent. Looks like my graphs didn't turn out too good here. Again, here's your origin at 0, 0. When I look at my parent over here, inside the parentheses, I have a +5. So that means I'm going to then move the opposite, left 5. And here I have a +2, so then I'm going to go up 2. So start here at the original origin at 0, 0. Go left 1, 2, 3, 4, 5, and up 1, 2. And there is my parent. And you can kind of see from the left it goes up like this and like this and makes that V. So there is my new translated function. So you try the second one. The third function we have is y is equal to x to the third power, which is called a cubic. So I'll put cubic here. And you can see the way it looks. Again, you can't really see. Here's, you can see the arrow here. This is my x-axis. Here is my origin right there. There's my 0, 0 right there in the middle. And so in my translated one, and I can tell what it is by looking right here. This is x cubed, and that's what's going to indicate what's going to happen. In the original one, there was a square here, and that was going to be a parabola, but because this is a 3, it's going to be a cubic, and it's going to look like this parent over here. So you've got to learn to recognize that number there and know what it's going to look like. So I'm going to come over here. This one's going to move because it's minus 3. Right 3, and then minus 1 is going to be down 1. So I'm going to go right 3 from the origin, go right 3, and then down 1. And so there's my new origin right there. All right, so then I'm going to look over here to the left and see that I've got this point, which appears to be over 1, up 1, and this point here, which looks to be from the origin over 1, down 1. Kind of makes a line like that. And then because it's a cube, if I put in a 2, 2 cubed is 8. So from here, if I go over 2, I'm going to go up 1, 2, 4, 5, 6, 7, 8. And then again from here back 2, down 1, 2, 4, 5, 6, 7, 8 here. So this graph then would look like this kind of curve. But you see it has the same shape as the parent, and that's because of that 3 right there. All right, so you try this next one here. The square root function. Now the square root function stops. Right there, you see it stops and is not on the left side. So its domain is does not include the negative numbers for there. So it always has that one point. And again, that's the point I'm going to be interested in graphing. That's my important point for a square root function. And you see my square root. So I come over here and I see the square root. So I know that I'm going to use this parent right here. It's going to move left 2 and down 6. So again, starting from that important point, I'm going to go left 2 and down 1, 2, 3, 4, 5, 6. And I'm going to mark my new origin right there. And then you can see when I look at this, you can see the over 1, up 1. So I'm going to go over 1, up 1. And then this is over 1, 2, 3, 4, and up 2. So again, over 1, 2, 3, 4, and up 2. And here's my function right there. So you can see it has the same look, but it's in a different spot. So now you try this next one. This function that we're going to graph is the cube root function. And we've graphed those by plugging in values for x and figuring out y and plotting them. And again, you can't really see the y-axis there, but there is the middle right there. So this right here is my 0, 0, and that's what I'm going to translate first. So when I look here inside my cube root, and again you see it, that's how I recognize it, it's a cube root. The x isn't moved left or right, so the x is going to stay where it is. We don't move the x's, and but we're going to move the y's. And in this case, we're going to move it, since it's plus 3, we're going to move up 3. Now, can you tell that that 3 is on the outside? It is not on the inside with the X, and that's why it's moved up 3 rather than left 3, because it's on the outside there. So I'm going to move from the 0, 0, I'm going to move up 3, and there's my new origin. Then when I look at my graph over here, it's over 1, up 1. So I'm going to go over 1, up 1, back 1, down 1. And on a better graph, you would be able to see, I think hopefully yours is a little bit better. You're also going to go from here. You're going to go over 1, 2, 3, 4, 6, 7, 8, and up 1, 2. And then back 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2. So it is going to look like that. Again, same shape, just up 3. So you try this next one. So I believe I'll stop right now and I'll pick up on the next video.